You know, you had. Oh, I'm gonna pause this, otherwise I might get in trouble. So yesterday we talked about the fact that, right, um, if you just make sure you pay close attention. If you're ever confronted, if you're ever given all three, the measurement, the item you use to measure it, the measuring device, or it's said in words what it's marked in, you're going to go with the words, right? Usually not going to be the case. At most, you have two at the same time, not all three. But this one always trumps everything. Then that's not going to be the case. That's a good question, actually. Like between these two, they should jive, right? They should, yeah. This one you should be able to see the markings on here, and that measurement should be stated in the precision that the instrument is given. Okay. Maybe let's just review one or two from the past, but I want to actually do something new right now. If so, you have a something that is measured. So there's the value, and what does it say next? Marked in centimeters. Value, words. And this is the one that wins. Okay, that's where you get your precision from. So precision is 1 centimeter. The uncertainty is half of that, which is 0.5 of a centimeter. Got it? And so if they ask you to write the height as measured value plus or minus the uncertainty, this is somewhat strange, but it is okay to have different units. It's okay to have different units as long as you state them, right? If you were to just put 1.75 plus or minus 0.5 centimeters, that is wrong, because then we are assuming that this is in centimeters also, right? And it's not. This is in meters, this is in centimeters. So there you go. And then it's asking, what is the range of possible values of the actual height? And yesterday we talked about range, just up here, right? What is range? It's taking the greatest possible value minus the smallest. Okay, that difference. And so how am I going to do this? Oh yeah, this is how I will do it. When you add these, you can't add meters and centimeters. Do you remember how many centimeters there are in a meter? How many cents in a dollar? 100. So therefore 100 centimeters, right? So 1 meter has 100 centimeters. So we can just times this by 100, right? So 1.75 times 100, that's 175 centimeters. So I'd like to, for this example, doesn't happen very often. You are saying the exact same thing, talking about this exact same height, but this is better. We can get our max from this, and we can get the lowest possible, the minimum. Right? So 175 plus 0.5 is 175.5 centimeters, and then you would go 175 minus 0.5, that is 174.5 centimeters. So this height could actually be, this person could be this tall or this tall. We don't quite, there's a bit of an uncertainty there. So the range would be 175.5 minus 174.5, and that is actually 1 centimeter. I don't know if you notice a pattern, but don't assume it's always going to be the case, but it's the same as your precision, right? Just keep that in mind. And now this is the new part. This will be on the AC. This for sure will be on the AC, stuff like this. What we did yesterday, day before, figuring out the precision on the uncertainty, stating the measurement with its uncertainty, same thing. Remember, you first need to get your precision, no matter what. So let's go to page 87. Adding and subtracting values with uncertainties. If you have a highlighter, I'd like you to use it for this part. When adding or subtracting measurements that each have an uncertainty, the combined value will also have an uncertainty, right? The combined value will also have an uncertainty. It's called the combined uncertainty. The combined uncertainty. Okay. Continuing. So let's do that example. Marcy is a carpenter. She's installing sheets of plywood as subflooring on a balcony. She measured two of the sheets. One is 2.25. The other one is 1.30 meters long, using a tape measure marked in centimeters. I don't like that question, so watch what I'm going to do. I'm just going to, it makes this problem too convoluted, too complicated. So I'm just going to stick with this, okay? And so write the length of each sheet of plywood in the form measured value plus or minus the uncertainty. We're going to do that right up here. Let's figure out the precision for this one is 0.01. Same with this one, correct? But you're like, Mr. Dirksen, there's a 0 there. It doesn't matter. It's the precision of the element. That's how close you can get to the nearest 0.01 of a meter. Therefore, the uncertainty, right, just do this once, right? You divide it by 2 to get that, and they both will have the same uncertainties, correct? They will both have the same. And that's 0.005, 0.005. So we will write it like this. Sheet number 1, right? So that's 2.25 meters plus or minus 0.005 of a meter. And this is 1.30 meters plus or minus 0.005. They both have the same uncertainty, and that's how you would do A, right? That's how you would answer it. Now, what is the total length, including the uncertainty, of the two sheets if they're placed end to end, right? So you're taking one of the sheets is a little longer than the other, right? You're taking one and you're putting one right next to it like this, right? We know that this one is 2.25 and the other one is 1.30, okay? So we want to know how long would this piece be with the uncertainty. Now, what do you need to do? Add or subtract them, these two values. You'd have to add them, right? Like the problem will tell you what you need to do, right? Like the context should tell you. So watch this is how this is different. Now we're having an uncertainty. So we'll do this. Do this with me. 2.25 plus or minus 0.005. 1.30 plus or minus 0.005. We're going to add them. Okay, you add that up, and on this side you get 3.55 meters plus or minus. You need to add this up as well. Okay, so make sure a decimal place is a big deal here. So if you know how this is done, great. If not, use your calculator, right? But this is the combined total length with its uncertainty. Okay. If you had, let's say you had 3 sheets, like 1, 2, and a third one, you would do the same thing and you would add up all the uncertainties. And the reason being is the more you add to something, right, every time there's a little bit of uncertainty here and a little bit of uncertainty there and a little bit, right, every time you add to something, it actually combines, right, the uncertainty. So my example is always this. Anybody ever flown before? You got on an airplane, right? What do they do with your luggage? They weigh it, right? They weigh it. So they have a scale, but that scale has a little bit of uncertainty, right? So they keep on weighing everybody's luggage, and then at some point they have some kind of threshold, right? They can't surpass it or else it's too heavy for the plane, right? But every time they added the weight, there's some uncertainty that keeps on building up, right? So they can't just let it go up right until the limit, right? That wouldn't be too smart, would it? They would have to like keep it down a little bit because of this. It's the same phenomenon happening there, right? One more, and then I'll let you try this on your own. Junior has a bucket of water with 20.5 liters in it. He needs to draw some water for some plants using a smaller jug that can hold 1.2 liters. If Junior draws 3 jugs from the bucket, determine how much water will be left in the bucket, including the uncertainty. So hold it. Let's figure this out. The 20.5 liters has a precision of, like if you just look at the amount in there, it's 0.1, right? Therefore, the uncertainty will be half of that, which is that. And then the little jug, it's telling us that it's 1.2 liters. The precision is the same. This will change very quickly, okay? But for this example, we keep it simple. So what's happening here? Are we adding or subtracting? We're starting with a bucket, and we use that uncertainty, right? Right, you're taking a small jug and you're scooping out of it, right? You're scooping out, so this is a little longer than you would probably like it to be, but at 1.2 liters plus or minus, it has an uncertainty, right? That little jug has an uncertainty. You take another scoop out of it. I see where this is going, right? You subtract, because you took 3. Where is that 3, right? You draw 3 jugs from the bucket, right? That's why it's happening 3 times, right? Right, let's do this. And you can just go 20.5 minus 1.2 minus 1.2 minus 1.2, or you already figured it out, right? It's 3.6, right? But that leaves you with 16.9 liters. And here's the kicker. When it comes to uncertainties, you have to add them no matter what. No matter what you do here, This may be added or subtracted depending on the scenario. You add them, okay? So we add uncertainties. You add uncertainties. So because they're all the same, can I do this? 0.05 times 4. Can I just multiply it by 4? You bet, right? So that is now your combined uncertainty. And if you want to, yeah, and that's also in liters, by the way. So this is what the question is asking. What's left over? And there's a little bit of uncertainty. So how much could be left in that bucket? There's a max and there's a min. There's a possible difference. It could be as much as this or as little as that, right? To get the max, you just add it. To get the min, you just subtract. 17.1 liters or 16.7 liters. That's how much could be in there, anywhere in between actually. Okay. So this, it didn't ask for this specifically, but notice what it says in B here. If Junior needs 17.5 liters to water, of water, it should have said there, sorry, of water for a tree, will he have enough? And the answer is no, right? The maximum that could be possibly in there, considering the uncertainty that has now resulted from drawing 3 times, doesn't allow you, right? So B, not enough, will not be enough. Water, since the maximum amount remaining, is this English class or what? Is 17.1 liters, right? Okay. So one of the provincial exams had a long board and saying that this person made 50 cuts. Just cut up 50 like 1-inch pieces. And you wouldn't do it this way, guys. There's no way. Like, don't do it this way. That's way too time consuming, right? You would just go 50 times this, right? Subtract that from the starting amount. And then you would just go 50 cuts, right? 50 times whatever the uncertainty is. And that's, just make sure you also add that to the original uncertainty, right? So just keep that in mind. Read carefully and see what's needed to be done and be efficient, right? Let me see here. Before you do the AC, try page 88. Make sure you give it a try, like an honest try, not like a, I don't know how to do this. That's not trying, right? You need to kind of struggle with it a little bit. And I will go over them, and then we'll do the AC afterwards, okay? So this is the step that you need to do before you answer this. So you add these up. This is the combined weights and the uncertainty. So the max combined is 1495 plus 0.01, and the minimum is this. $16 heads up. That's where you get your precision from. Give it a try. Before the AC. Make sure you guys pay attention, guys. So you're preparing liquid fertilizer. Guys, I'm serious. Quiet. You can be quiet and not pay attention, but if you're not quiet, then I have a problem. Okay. You have something marked in half liters, right? And you wanna, there's a bucket marked in half liters, and you wanna fill it with 4-liter fertilizer mixture. Write the volume of the liquid in the bucket in the form measured value plus or minus the uncertainty. Before you do that, you deduct from this that the precision is half a liter. Therefore, the uncertainty is not, you know how you're so used to always it being 0.05 or 0.005? In this case, it's not, it's this. Okay, so we base it on the markings. So in this case, it's 4 liters plus or minus 0.25 of a liter. That's the correct answer in that case. Com uses a small jug marked in 125 milliliter increments. Remember increments, what it goes up by, the markings, all of that is also the precision. So the precision is 125 milliliters. Okay. To remove 375 milliliters of the mixture from the bucket, write the liquid of the small jug measured value plus or minus uncertainty. So we'll do that 375, right? 375 milliliters plus or minus. You're going to be tempted to write down 125, right? But it's not. The uncertainty is half of that. What would that be? 62.5 milliliters, right? You just took this and divided it in half. So that is 62.5 milliliters, like that. So that's how you would write that particular one. Okay, pause here, pause. If this hadn't been there, let's say the markings had not been there, what would have been my precision if I just look at this number? Think about it. What would be, if based on this, if it's a little bit more, it would be 376. If it's a little bit less, it would be 374. So it'd actually be 1 milliliter. That's the precision of that tool if this hadn't been there. Okay, so be careful with how it's worded. What is the volume of the liquid left in the bucket? Write your answer in the form measured value and uncertainty. So volume left. Okay, we have a bit of a problem here, right? We have liters and we have milliliters. But it's actually not that big of a problem. Do you know how many milliliters are in a liter? Anybody brave enough there's 1,000 milliliters in a liter. Right? So 4 liters would be 4,000 milliliters. And 0.25 of a liter would be how many milliliters? Just go ahead and multiply that by 1,000, right? And so that's 250 milliliters. It's a quarter of a liter, right? So what we're going to do here is we're going to take the 4,000 milliliters plus or minus 250 milliliters, and we're going to subtract the amount in the jug. Oops, sorry, 0.5. Why are we subtracting? The question says, right, you use a small jug to remove, right? That's dead giveaway, right? You're removing. And so it's kind of like you're subtracting the amounts, but you're always adding the uncertainties no matter what. Okay. So what are you left with here? 3,625 milliliters plus or minus. We add this up, and that is 312.5 milliliters. You're like, whoa, it's too much going on here, right? Why did this step have to be in there, right? Well, you need to be prepared for minor conversions, but not quite often. Like it's not very, very common for this to happen. So now they could ask you, what's the maximum and minimum combined amount that would be left in the big jug? You can branch off and say max and min, right? Off of this, but you need to get to this before you figure that out. Okay. You want to do that or no? More work? Kidding me? More work? I think I will do it and you decide. Right? You should be able to. And this is the combined, right? Like what is left after you've removed or added to something, right? Okay, so we've got 3,937.5 milliliters. Or 3,312.5 milliliters. So it could be as much as this in there or as little as that. Right? And if you would have taken even more out, right, then it would have affected it even more. So you got to almost think that the uncertainties keep on piling up and up and up, right? And you've experienced this. If you've ever been in woods, like if you ever did some woodwork, you cut that first piece and then you use that piece to mark off your next piece. If you were to take that second piece to mark off your third and you keep using the next one, your pieces would slowly get longer and longer, right? Like you want to stick to that original. Otherwise, this is what's going to happen there, right? So you got to watch out for that. Okay. I think we're ready to write our AC.